In this tutorial, I'm going to talk about recursion. I'll explain some of its basic properties and walk through an example with you. So what is recursion? In simple terms, recursive functions are functions that call themselves. There are two main properties of recursion functions, one of which is pretty self-explanatory. It does have to call itself within its definition. It also has to have at least one base case. This is really important to any recursive function. If a recursive function does not have a base case, it will infinitely call itself forever, or at least until you get an error. One of the most common examples of recursion is a factorial. Factorials are great examples because they follow the two rules of recursive functions. They call themselves and have a base case. The code on the left is an example of the implementation of a factorial function. This function has the two main properties of recursive functions. One of these properties is that it has a base case. The base case of the factorial example is n equals 1, where 1 factorial is equal to 1. The function is also called within itself, as shown by the code in orange. You should note that the input into the function has changed from n to n minus 1. This is important because this will cause n to eventually meet the conditions of the base case. You want the base case to be called at some point to stop the recursive function. So I want to show you what this would look like if you were running this program from the terminal. I have my entire class to the right and the text from the terminal in the left-hand corner. I also want you to see how the computer is processing our function. When I press enter into the terminal, it will call the main function and take in the user input. In this case, the number given to the program is 4. Then the computer will convert the string 4 to the integer 4. Then you will want to print out the answer in the terminal. This will call factorial 4. In the upper left-hand corner, there is a schematic which shows you where we are in the recursion method. Right now we are calling 4 factorial. 4 is not the base case, so we'll skip to the else statement. Next, we will return 4 times factorial 4 minus 1, or 4 times factorial of 3. So now we have to find factorial of 3 in order to solve factorial of 4. So let's call factorial of 3. Again, we find that it is not the base case, so we go to the else statement, and it's the same pattern. We split factorial of 3 into 3 times factorial of 3 minus 1, or 3 times factorial of 2. And then we call factorial 2 to solve for factorial 3. Again, 2 does not fit our base case. We move to the else statement and call 2 times factorial of 2 minus 1, or 2 times factorial of 1. We then call factorial 1. This does fit our base case. So we return 1. We can then solve for factorial 2, which is 2 times factorial of 1, or 2 times 1. From here we can solve for factorial of 3, which is equal to 3 times factorial 2, or 3 times 2. Then we can finally solve for factorial 4, which is 4 times factorial 3, or 4 times 6. Our answer is therefore 24. In the end, the terminal will print out the answer, which is 24,